Good morning, children. Welcome back to Ican Physics. Now, in this class, we are going to see the resistors in series and parallel. Let's enjoy the class. So, the next topic is the resistors in series and parallel. So, first one, we are going to see the resistors in series. Okay. So, let us consider a resistor of a resistance R1 and a resistor of a resistance R2 and a resistor of a resistance R3. Okay. Is connected with a external source. Okay. So the external source gives a potential of V. Okay. Now the potential drop across the first one is V1. The potential drop across the second one is V2. The potential drop across the third one is V3. So what about the total potential? The total potential equal to V1 plus V2 plus V3. So what about the current? So current flowing through the first resistor will be same and also same. So the current flowing through each resistor will be same. So we know very well that V equal to IR. Okay. So for V1, we can modify the first case. So how we can modify the first case? V1 equal to I into R1. For the second case, V2 R2, I will be same. So V2 equal to I into R2. But what about the third case, V3 I3, then current will be same. So V3 equal to I into R3. First general case, V equal to I into RS. Okay. So why we are writing RS? Because the resistors are connected in series. Okay. Now you can add. So V1 plus V2 plus V3 equal to. So I can be taken as common. So I is taken as common. So R1 plus R2 plus R3. Now, for instead of V1 plus V2 plus V3, we can write V. Okay. So, V equal to I into R1 plus R2 plus R3. Now, taken as 2. Compare 1 and 2. LHS are equal. So, automatically RHS are equal. So, I into RS equal to I into R1 plus R2 plus R3. Now, I getting cancelled. So, RS equal to R1 plus R2 plus R3. Okay. So, the effective resistance in series is equal to the algebraic sum of resistance of individual resistors. Okay. Do you get it now? Do you have any doubts? No doubts. Okay. So what about the second topic? Is the resistors in parallel. Okay. So a resistor of resistance R1, a resistor of resistance R2, a resistor of resistance R3. Okay. So it is connected in parallel. Okay. Okay. So when it is connected with the external source. Okay. The external source is V. Now the current I flows and comes to the junction. When it comes to the junction, it splits into 3. So in the first arm, it can be taken as I1. In the second arm, it can be taken as I2. In the third arm, it can be taken as I3. Now, here, all the terminals are connected at one single point. On the other hand, here we are having all the terminals are connected at a single point. So that the potential will be same. The potential will be same. But what about the current? Current equal to I1 plus I2 plus I3. So I1 plus I2 plus I3. Okay. So we know that V equal to IR. V equal to IR. Here we are having V1, V2, V3. So that we calculated V1, V2, V3. Like that. Here we are having I1, I2, I3. Then we can calculate the value of I. So the multiplication R comes with this as division R. So V by R equal to I1. But what I said, we are going to calculate I1, I2 and I3. So for this case, I1, R1. How we can modify this formula? That is I1 equal to V by R1. For the second case, so I2 equal to V by R2. For the third case, so I3 equal to V by R3. For general case, sorry, I1. For general case, I equal to V by RP. So why we are taking RP? Because the resistors are connected in parallel. Okay. So now we can add. So when we add I1 plus I2 plus I3 equal to, in all the terms, V as common. Okay. So it is taken as common. So what about the remaining? 1 by R1 plus 1 by R2 plus 1 by R3. Okay. So I1 plus I2 plus I3. I1 plus I2 plus I3 can be taken as I. So I equal to V into 1 by R1 plus 1 by R2 plus 1 by R3. Now compare these two equations. I are equal. Automatically other sides are also equal. So V by RP equal to V into 1 by R1 plus 1 by R2 plus 1 by R3. Now V getting cancelled. So that we can write 1 by RP equal to 1 by R1 plus 1 by R2 plus 1 by R3. Okay. So the effective resistance in parallel is defined as algebraic sum of reciprocal of resistance of individual resistors. Okay. Do you get it now? Do you any doubts? No doubts.